This video is sponsored by Linode. Anyone can build on Linode, whether you need a development portfolio to land your next job or you're ready to put your app into production. Linode can get you there. For $20 in free hosting credit, click the link below or sign up at linode.com/Traversy. Hey guys, welcome to my Canvas crash course. So Canvas is an HTML5 element that has an API that we can use in our JavaScript to basically draw things on the canvas. We can create shapes and paths. We can do animation. A lot of the times the 2D games you play in the browser use Canvas. You can even do 3D stuff with WebGL and some other libraries. But this is basically an introduction to Canvas. And we're going to look at drawing shapes and paths as well as a little bit of animation. And what gave me the idea for this is the new Udemy course I'm working on, which is a 20 vanilla JavaScript project course. We build this little breakout game using Canvas. So you can see we can move the paddle and hit the ball and break the bricks, and when it hits the bottom it resets. So pretty simple, but I realized when I was building this that I don't have any Canvas videos on my channel, so I wanted to do a crash course, and then maybe later on down the line we can build some games. All right, so let's go ahead and jump into our VS Code, and I already have the HTML and CSS done because it's very, very simple and I didn't want to waste time on it. So we just have an H1 and then a canvas tag, which is extremely important. This is what allows us to use this API. And I have an ID of canvas with a width and a height of 600. And then I'm just linking a style sheet and a script.js. So the style sheet, very, very simple. Just a background color. I'm using Flexbox in the body to center everything, and I made the canvas a light gray color. Okay, so that's it for the HTML CSS. If you want to pause the video and copy that, if you're following along, you can go ahead and do so. But we're going to jump into our JavaScript now. So the first thing we need to do is bring in the canvas just like we would any other DOM element. So I'm going to use document.getElementById, and it has an ID of canvas. Okay, now we need to create what's called a context. So I'm going to open up the docs real quick. And so the MDN docs are really helpful, and there's a lot in here, and you can use this as kind of a supplement to this crash course. So right here, the actual drawing is done using something called a Canvas Rendering Context 2D interface. Okay, so that's what we have to create. We do this by calling this getContext method and setting that to a variable, and then we can call all these different methods and properties on that variable. All right, so let's close that up and let's create a variable called CTX. That's kind of the convention, and set it to canvas.getContext, and then we pass in a string here of 2D. Okay, so this is a 2D context, and if you want to check for support, you can say if and then just use canvas.getContext. So you can do that. However, all the modern browsers support it, so I don't do that anymore. Also, if you want access to the width and the height of the entire canvas, you have those properties, and you can actually set those here as well. So if I go ahead and set that canvas width, wait, why is this not? Did I not save this? Oh, I have this going to JS script. There we go. So you can see that I can set the width. If I wanted to set it to the whole entire width of the window, we could use the window object, and we could call inner width like that. Okay, so take the whole width. You could do height as well. So I just wanted to show you that that's possible. All right, now let's start to work with rectangles, because we have a few methods that we can use to create rectangles. The first is FillRect. Okay, so we take our context and we can call .FillRect, and this takes in 4 arguments to pass in. The first are going to be the X and Y values, where we want to place this. And I just want to show you an image real quick. So when you work with Canvas, you can think of it as a grid, and you have the x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. So the first 2 values here are going to be x and y. Where do we want to place the rectangle here? So I'm going to set it to 20 on the x. So from here, we'll go 20 over, and from 20 down on the y. So I want it to be like right around here. So let's pass in here 20 for the x, 20 for the y. The second 2 are going to be the width and the height of the rectangle. So let's do 150 width, 100 height. And there we go. So we draw a rectangle, pretty simple. If we want to change the fill, we can set the fill style, and we can set this to a named color like red. You can also use hexadecimal or RGBA or something like that as well. So now we just have a red rectangle. We can create multiple rectangles. So let's move this over. Let's say, yeah, we'll move this to 200x, which will, start somewhere over here, about 200, and we'll keep it at the same Y value, and then keep the same dimensions. So if I save that, we have another red rectangle, and if we want to change this fill style, we can simply create another fill style property right above it and set that to something else. And we can also place it on top of the other one if we want. So if I set this to like 50, you can see that it'll go right over it. All right, so pretty simple. Next method we have is StrokeRect. So this will create like an outline of a rectangle. So if we take our context and we call StrokeRect, and it takes in the same values, we're going to do let's say 100 on the x-axis, 200 on the y, and then we'll do the same dimensions. And you can see we get an outline of a rectangle, and there's some methods for this as well, such as stroke style. We could set that to, let's say, green. If we want to change the line width, we can do that as well. So line width, we'll set it to 5. Okay. And then the next one we have is ClearRect, and not React. ClearRect will actually clear out part of a rectangle, and this is used often in animation because you need to clear the whole canvas basically on each paint, and we'll get into that later. So let's say we want to clear like the inner of this rectangle here. So I'm going to call my context ClearRect. I don't know why I keep writing React. And let's place this at 25 on the X and Y. So this rectangle is at 20, so this one will start like right here. And then let's make it a little smaller than the rectangle we're putting it over, so we'll do 140 by 90. And if we save, you can see that it cleared out that entire part of that rectangle. Okay, so those are the three main methods for rectangles, and you can create rectangles with paths as well, and I'll get to that in a little bit. So let's look at text before we move to paths. So there's a method called FillText. So let's take our context and call FillText, and let's put this, we'll say 400x, and let's move down 50 from the y-axis. And I'm sorry, the first parameter is actually the text. So let's say, oops, hello world, save, and now you can see we have some text here. And in the breakout game that I showed you earlier, that's what we use for the score, is FillText. Now it's blue because it's looking at the last fill style. However, we can put a new one in here if we want to change that and set that to, let's say, purple. And if we want to change the font or the size, we can do ctx.font, and let's set that to 30 pixels Arial and save. There we go. And there's also a stroke text, although I don't use this that much, but it is available. So we'll say ctx.strokeText, and same thing, it's going to take in the text. And let's put this 400, let's move it down a little, so 100. Now the reason it looks like this is because it's looking at these two properties which have to do with stroke. So we can go ahead and change that here if we want. Say orange, save, and there we go. Okay, so this is like the bare basics of Canvas, creating rectangles and text. So now what I want to do is start to look at paths. So I'm going to just comment all this stuff out. All right, and then let's look at paths. Now I'm going to start off, let me just save that. I'm going to start off with drawing a couple triangles. We'll do an upside down triangle, and then we'll do a right side up one next to it. So with paths, we need to call begin path. Okay, so we're going to begin a path, and then I'm going to move to a certain spot before I start drawing the triangle. So we can take our context, and there's a method called move to, and this takes in your x and y value. I'm going to move to 50, 50, which is going to be somewhere around here. So 50 over on the x, 50 down on the y. Okay, and then I want to draw a straight line. So there's a method that we can use called line to. And I'm going to, like I said, make an upside down triangle. So I want it to go from where we are now to about here. So let's go over to 150x. So line to 150x. I don't know why I just typed the x. But we want to stay at 50y because it's a straight line. It's a straight horizontal line. Now it's not going to show anything yet because we have to actually call stroke like that. And now you can see we have our line. So we moved to 50, 50, and then we drew a line to 150, 50. Okay. Now the next thing I want to do is go from here down to about here, okay, to the middle. So let's create another line from where we're at. So we'll say line 2. Now let's think about what should go in here. And if you want to pause the video and try to figure that out yourself, you can. So we want to be in the middle. Okay, we're going to be down here, which is in the middle of that line. So that line is 100 wide, right? It goes from 50 to 150. So what do you think the middle would be as far as the x value goes? The middle is going to be 100, right? So let's say 100 for x. As for the y, which is, this way, I want to go down to about here. So let's do 200 on the y-axis. And if I save, there we go. Now, to get back to the beginning, we want to go from here to here. That's pretty simple. We just want to use the beginning coordinates, right? So we'll do a ctx dot line 2, and we want to do, 50, 50. And that will complete it. Now there's a method we can use called close path as well. So if we do close path, that's going to draw a straight line to the beginning. Okay, so either one of these will both give the same effect in this situation. Now in addition to stroke, we also have fill. Okay, if we want to fill it, so we can do ctx dot fill like that, and it will fill the triangle. Okay, but it has to be a complete path or a complete shape in order to fill it. And we can also change the style. We can use fill style, just like we did with the rectangle methods. And we'll set that to, let's say, coral. Okay, so that's our first triangle. Let's draw another one next to it. So for this, I'm going to ctx begin another path, and let's move to. So we'll do ctx dot move to. And I'm going to go like right here. So we're going to have the point right here, and then it'll go down and like that. So let's move over to 200x. And we'll stay at 50y. And then we want to draw a line. So remember, this is going to be the point. I want to draw a line down and over. So we're going to go down and to the left. Okay, so for the x value, let's say line 2. For the x value, it's going to be, let's see, we're at 200, and it's going to be 100 wide, so the x value should be 150, right? We're going to go from 200 over to 150. Never mind going down yet, but it's going to be like over here on the x. So let's say 150, and then as far as the y value, I want it to end where this one ends down here, which is 200, right? So let's do 200 here and save. Oops, we have to do ctx stroke, save, and now we have a line. So we started at 250, so 200x, 50y, and we went down to 150x, 200y. Now I want to go over. So remember, it's 100 width. I want it to be the same as this one. So we're at 150. So if we want to go 100 over on the x-axis, what's that going to be? It's going to be 250. So ctx dot line 2, and we want to be 250 on the x-axis, and we still want to be at 200 on the y because we're not going up or down, we're just making a straight line. Now, to close it, we could either do line 2 to the original position, or we can just do close path like that. Okay, so pretty simple. We can also do rectangles using paths. So let's go down here and let's do ctx dot begin path. And then I'm going to move to, actually, you know what? We don't even have to do a move to, because the rect method that we're using, the first two parameters are where we want it to be. So we can just place it, let's say 300x, 50y. And then the next two are just the width and the height. So we'll do 150 wide, 100 high, and then let's do a ctx dot fill. Okay. And we can change the fill style if we want. So ctx dot fill style, and we'll set it to teal. Okay, so that's how we can create a rectangle. And I'm just going to put, let's say, triangle, rectangle. So now what I want to do is work with arcs or circles. So for an arc, let's see, let's begin our path first. And let's say CTX, let's actually comment out this stuff here. All right, so we'll do CTX arc. Now this is going to take in a few things. In fact, I'm going to show you the documentation on this. So if we go over to drawing shapes, okay, so this shows you the grid, the rectangle methods. This is all the stuff I just showed you. Begin path, close path, stroke fill. So these are all important methods to know. Line to, move to. Let's see, where is arc? Right here. So arc takes in an x and y value. Now the positioning for x and y is going to be the middle of the arc, okay? Or the middle. If we're making a full circle, then it's the middle of the circle. And then we have the radius, which is the size. Then we have the start angle, the end angle, and if it's anti-clockwise or not. This is a Boolean. If it's true, then it's going to draw it anti-clockwise. If it's false, it'll draw it clockwise. All right, and you can see, let's see, right here where they drew these faces. So the arc takes in the x and y values. The radius in this case is 50. And then to make a perfect circle, for the start angle, you can pass in 0 and then math.pi times 2 for the end angle. And that'll give you a full circle. If you want a half circle like the mouth, you can do 0 for the start angle and math.pi for the end angle. So let's go ahead and draw here. Let's say we'll go 50. Actually, let's go in a little further. So x 100, y 100. That's going to be the center of the circle. We'll do a 40 radius, 0 start angle, and then math.pi times 2 for the end angle. So if I save that and we take a look, we're not going to see anything because we have to do CTX. We can either do stroke or fill, and there's our circle. Now, what I'd like to do is the little smiley face thing that they have in the docs, but I want to make it big. I want it to take up the entire thing here. All right, so let's actually, yeah, so this arc right here, I want it to take the entire thing. So instead of just putting in these numbers, hard coding these numbers in for x and y, let's put in the canvas dot width. So this is for the x, the canvas width, which is in this case 600, and then divide it by 2, which will give us 300, which will put it right in the middle horizontally. So for the y, we'll say canvas dot height, and we'll divide that by 2, and that will put us right in the middle vertically. So if I save that, it puts it right in the middle. Now I'm going to change the radius, make it bigger. Let's make it 200. Okay, now that will, let's just say, draw the head. Okay, now we're going to be using these two equations quite a bit, just dividing it by 2. So I'm going to go ahead and just create a couple variables here. We'll say center x equals that, and for the height, let's say center y, and then we can just plug those in here. Center x, center y, and that'll give us the same thing. All right, now I want to draw the mouth, so before we do that, we need to actually move to a specific position to draw it. So we're going to say ctx.move to. Actually, let's put a comment here. So move to mouth. So we're going to move to center x, center y. Now that will put us right in the middle. However, we want to start at the right side of the mouth, which will be like right here, and then we'll draw it like that. So we want to go to the x, but then we want to go plus 100, because we're going to go from the middle plus 100 to move it over, but stay in the same y value. All right, and then let's go down here and let's say draw the mouth. So to draw it, we're going to do ctx.arc. And we want to pass in here our center x. Now the middle of the mouth of the arc is going to be the middle of the circle, or I should say the middle of the canvas. So it's just center x and center y. Okay, and then we want the radius, which I'm going to put 100, which is half of the circle, and then start at 0, and then math.pi. Okay, not times 2, because I want it to be a half a circle. Now this parameter, this anti-clockwise, we want this to be false because we want it to be clockwise. We want it to go from here, draw it this way, which is clockwise. So let's save, and there we go. If we have this set to true, it's going to be upside down because it's going to draw it anti-clockwise. Okay, so you want to make sure that's false. Now let's do the eyes. So we'll say move to left eye. So ctx.move to. So we're going to go, let's start in the middle. So center x, center y. Right? So we're going to start here, but we want to end up here. So what I'll do is for the x, let's minus 60 because we want to go back. We want to go from the middle back. So I'm going to minus 60 from the x, and we want to go up to about here. So let's do from the y minus 80. So that should bring us to the right spot. Now let's draw the left eye. So ctx.arc. And remember, the first two are the x and y of the middle of the eye, or the middle of the circle. So we're going to take center x, and let's minus 80, and then center y minus 80, because we're going up and over. Okay, and then it's going to be for the radius, we'll say 20, and then a full circle, so we can do 0, math.pi times 2. And there we go. So we have our eye. Now, if I don't have these move tos, let me just comment these out. It'll actually show you the paths that we took. Okay, so we went from here to here, drew that, went up here. So we need these move tos in order to not show these lines. Okay, now we want to move to the right eye. So that's going to be from the center, right? So let's do context move to. Let's say center x, center y. So from the center x, so on the x position, we actually want to go over, right? Just like we did with the mouth. So let's add on to that 100. And then we still want to go up, just like we did over here. So center y, we're going to do negative. Okay, because if you want to go up, that's going to be negative. If we were to add 80 to y, it would go down. So from there, let's make the radius, which is 20, 0, and oops, I'm sorry, this is for the actual arc. We're just moving to this spot. So now to draw the right eye, we'll say ctx dot arc, and the middle of the eye, so center x. So let's add 80. Now we didn't add 100 because we're basically, when we draw the eye or the circles, we're starting here. So we don't want the middle to be where we're starting. We want it to be over a little. So we're moving to 100, which is going to be to the side of the eye, but the middle of the arc is going to be a little bit over. So that's why this is 80 and that's 100. Okay, and then we'll do center Y, and for this, let's subtract 80 because we're going to go up to the same place. And then 20 radius, start angle, end angle. Save, and there we go. Okay, so we have a nice little smiley face. Now, there's other curves that you can do as well. So an arc is like, it's a circle or a half circle or just like a, it's all the same really. There's also curves like Bezier curves, which I'm not too good at, so I think we'll just kind of look at the documentation and I'll just kind of explain right here. So we have Bezier and quadratic curves, which are like this. Okay, so they're not like perfect round like a circle or like an arc. So the difference between a quadratic curve and Bezier curve is quadratic curve only has one control point. So this is a control point. If you've ever used like Adobe Illustrator or something like that, you've probably created these curves, or you grab the control point, you can move it, and you can change the way the curve is. So with a quadratic, we only have one point. So the first two arguments are going to be the x value and the y value of that point. For a Bezier curve, we have two different control points, so it takes in the x and y for the first one, the x and y for the next one. All right, and then you have the positions, the x and y positions for both. So I'm not going to actually attempt to do something custom here. I'm just going to show you if we grab this, which is a quadratic curve, and let's just put that right here and put a comment. So that'll make this little speech bubble. So again, this is taking in the control point x, control point y, which is at 25. So I don't know, somewhere around here, I guess. And then we're at this x and y values. And then it's connecting them all. So if I just do the first one, for instance, that's what it gives us. Okay, if we do first two, gives us that. So I'm really bad at this. I don't think I could draw something using this just because it's confusing to me. Mostly when I do Canvas, I'm usually working with images, or I'm working with just straight shapes like circles and squares. This is a little confusing to me with all the coordinates, but I did want to include it. Okay, so now what we're going to do is look at animation. Okay, so the fun part. So I'm going to comment all this stuff out. Okay, so now we have a blank slate, and we're going to start off with just kind of creating a circle or a ball that bounces around, just like you saw in the Breakout Game, just no functionality of the bricks or anything. So for this, what I'm going to do, actually let's put a comment. I'm going to say animation 1, because we're going to do two different things. We're going to do the ball, and then I'm also going to have the little character that we can move around. So what I usually do here is create an object for each thing that we're going to create. And in this case, we're just creating one single circle. And then put its properties in here, like where we want to put it on the x and y axis. So let's start this at 200x, 200y, and then the size, which is going to be basically the radius of the circle, and then we have a dx value, which I'm going to set to 5, and dy, which I'm going to set to 4. Now this is basically the increment that we want to make in terms of movement on the x-axis, and then the increment in terms of movement on the y-axis. Because when we use animation with Canvas, basically we repaint the canvas over and over, and we can change the position of things in that repaint. Okay, and this will make more sense when I get to it. But now that we have these properties, let's create a function to actually draw the circle. All right, and we don't have to break this stuff into functions, but it's cleaner to do it that way. So let's take our context and begin path, and then let's draw our circle. So we need to do an arc, and we want to take our circle object and take the x value for the x-axis position, and then take the y value. Should probably spell this right. Then we want the radius, which is the size. Then we want to draw a circle, full circle, so 0, and then math.pi times 2. Okay, and then let's give it a fill style. So we'll set it to purple or whatever you want to set it to, and then let's fill it. Okay, so I can now go down here and I can call draw circle. Now we only have one object on the canvas that we're working with. If you had more, like for instance with the Breakout Game, we have draw bricks, we have draw the paddle, and draw the score, and all that stuff. But in this case, we're dealing with one thing. Now I want to be able to animate this. So the way that we do this with Canvas is we have a function, and I'm calling it update because that's what it's doing, is it's updating the canvas. You can call it paint or animate or something like that. And we want to actually move the draw circle into there, okay? Or any object that we're drawing we want to put in here, and then just call update. So you can see that'll still show us the circle. Now the key to animation here is a function that's available to us called request animation frame, and this takes in a callback, which is actually going to be the update function. Now I'm going to just do a quick console log here of 1, 2, 3 and save, and nothing's moving yet, but if I open up my console, you can see it's logging 1, 2, 3 over and over. Okay, so it's basically repainting the canvas for me. Now I don't want to just log something, so I'm going to get rid of that. What I want to do is change the position of my circle. So let's and you can see the border of this. What's happening is it keeps drawing it over and over. If I get rid of this and reload, you see how the edges are nice and smooth, but once we run that, it's drawing it over and over in the same position, and you can see the border is getting kind of sloppy. Now I don't want it to keep drawing in the same position. I want to change the position. So let's go ahead and say change position. Okay, and I'm going to take the circle.x, which is the x position, so the horizontal position, and I want to append to it. So plus equal will append something, and I want to append whatever the dx value is. Okay, so if I save that, now it keeps drawing it, and it's in a new position. It's basically incrementing by 5 every paint. Now the reason it doesn't just move the ball and it kind of extends like that is because we're not clearing the canvas each time, and we need to. So up here is where we want to use that FillRect that I showed you about, except we want to start at 0, 0, which is the very top corner, and we want to clear the entire thing. So the width is going to be the whole canvas width, and the height, and the height is going to be the whole canvas height. So now if I save, nothing's happening. That's because I didn't use my context. And there we go. So now it's doing it, but it's also clearing on every paint. Okay, so it just moves over. Now I want it to also move down. I want it to go right and down. So where we change our position, let's now take the Y position and let's append onto that the circle.dy value, which I think is, yeah, it's 4. So we save, and now it goes over and down. Okay, and the down speed, the dy, is slightly slower, because if we don't do that, I noticed it just bounces back and forth like this. Okay, so I want it to bounce around the canvas. Now the reason it's not bouncing is because we haven't added any kind of collision detection. So it just keeps going off the canvas. So now if we want to add some collision detection, let's say detect side walls. So I'm going to go ahead and add an if statement here. And the way that we do this is we just need to find the position of the circle and the position of the edges, and if they touch, then we need to do something about it. We can either bounce it off, we can stop it, whatever we want. So let's say if the circle X, okay, so I'm going to first work on this right side wall, which is at 600 pixels, right, or the width of the canvas. So let's say if circle X plus the circle.size, because we need to take into account the size of it because it starts on the left side. So we want to account for the whole circle. If that is greater than the canvas.width, which in this case is 600 pixels, then that means that it hit the side. So I'm just going to right now do a console log and just say hit. Okay, so now if I go over here and I open my console and reload, you'll see that right when it hits the side, it starts to fire off this hit. Now, I don't want to console log hit, I want it to actually turn around. So to do that, we just need to send it back the other way by setting it to a negative number, the negative version of this dx. So we can do that by saying circle.dx, and we can use this asterisk equals operator and set that to -1. So if you've never used that operator, it's just a shorthand for doing this circle.dx, and then we're setting it equal to circle.dx multiplied by -1, which will give us, in this case, -5. Okay, whatever this is, it'll give us the negative version, which will then send it this way. Okay, because positive goes this way, negative goes that way on the x-axis. So let's save, and there we go, it bounces right off. So now we want to handle the other way, because if I change the circle X right here, if I set it to the negative, that'll send it the other way, and it goes right through. So I'm going to set this, I'm just going to put an OR in here and say if the circle X position, now we want to minus the circle size in this case, because we're going to the left. If that is less than 0, which is the side, remember this is 0, and then this is the canvas dot width, which in this case is 600. So if that's true, we want to do the same thing. So let's save, and now it bounces off. So now it bounces off each side. I'm going to change this back to a positive. Okay, now we want to handle the top and bottom walls. So let's say detect top and bottom walls. So we're basically going to do the same thing, just with the height and with the y values. So I could actually probably just copy this. Okay, so we're going to deal with the y axis now. So if circle.y plus circle.size, because it has the same height and width, so size is we can use in both cases. And then we want to see if that is greater than the canvas height in this case, okay, because we're dealing with the top and bottom. So that'll handle the top. I'm sorry, that'll handle the bottom, because canvas.height, which is 600, is down here. This is 0, okay? 0, 600y, 0, 600x. Now we want to handle the top by saying if circle.y minus circle.size is less than 0, same thing. So now I'll save. Whoops, that didn't work. What did I do here? Circle. Oh, right here we're setting dx. This should be dy. And there we go. So now it's going to bounce off each edge. Okay, and you would do the same thing like in the breakout game. We do the same thing to see if it hits the paddle or if it hits the bricks. That's how you have detection or collision detection. So that's kind of the first basic animation that I wanted to do. Now I want to do something where we can actually control. So I'm going to comment this out because I want to keep all this here. Where are we? So let's comment that out. So if I save, that's going to just clear up. And let's say animation 2, we'll say character. All right. So this is going to be kind of the same type of deal. We're going to create what's called a player, or I'm calling it a player, instead of a circle, and it's going to be the little image of the wizard. Now this is going to have a couple extra properties. It's going to have a width and a height because it's not the same. Instead of size like the circle, we'll have width and height. So I'll do 50 width, height. Let's do 70. The x value, so we'll start it at 20x and 200y, which is going to be like right here. And then we're also going to have a speed value, and we'll say 5, and then dx and dy. However, dx and dy are going to be set to 0 to begin with, because in this case the thing isn't going to move automatically. It has to wait for our keyboard events, unlike the ball, which moves right away. Okay, so these are going to be set to 0. Now, to bring an image in, we need to actually add it to the DOM. So in the index.html, I'm going to add an image with an ID of source. And the source is going to be my little character, so char PNG, I think it's called. And then, yeah, if I save that, you're going to see them down here. However, in my CSS, I'm just going to set source to display none. Okay, so now he doesn't show anymore. Now we want to bring him into our JavaScript. Actually, I'll just do it down here. So let's say const image, set it to document.getElementById, and it has an ID of source. Now we want to go down here and let's create a function called draw image, or draw, let's call it draw player. And to do this, we just call our context, and it has a draw image method, which is going to take in the image. It's going to take in the where we want to place it. So I'm going to use my player object x value, that's the x, and then the y value, player dot y, and then the width and the height, which is also in the player object. So player dot width, and then player dot h. Okay, and then we're going to have an update just like we did with the circle animation, and then we're going to call draw player here, and then we'll call update here. Okay, so if we save that, we should see our little guy. All right, so as far as the animation goes, we're going to do the same thing. We're going to call request animation frame. So that will keep running. If I save that, you can see that it's getting darker around the edges because it keeps drawing the player. Now we want to change the player's position. Well, actually, let's clear it first. Now, in the last time I just put FillRect right here, but usually what I'll do is have a function, oops, to do that. So we'll just create a separate function called clear, and then we'll call FillRect. We want to start 0, 0. We want to go canvas dot width, canvas dot height. Okay, so let's see, that clears it. All right, now we want to basically change the position. I forgot my context again. I don't know why I keep doing that. So now we want to change the position based on our keyboard events. So let's have a function in here right under draw player. We'll call it new position. And then we'll add this up here. Oops, new position. And what this is going to do is set the player's x value to, well, not set it, but append. So we want to do plus equals whatever its dx value is. And then let's set player.y. We want to append to that whatever its dy value is. Okay, now it's 0 by default, right? In fact, if I were to change this to 4 and save, it'll just go and move 4 automatically. But I don't want it to do that. We want our keyboard events to move it. So let's go down here. We'll go, let's see, yeah, we'll go under update, and let's add in here document.add event listener. And we're going to listen for a key down. And when that happens, we'll call a function called key down. I'm going to do the same thing for key up. Okay, and then let's go up here and let's create a function called key down, which takes in an event parameter. And we'll also have key up. Now in key down, I'm just going to do a console log of my event parameter dot key, because that will actually show me which key I'm pushing. Because remember, we want the arrow keys to do this. We don't want to hit the letter A and have the guy move. So let's open up the console, and if I hit the up arrow, we get arrow up, arrow down, arrow left, arrow right, and then if I hit any other letters or any other keys, it also fires off. All right, so what I want to do here is check for the key that I'm hitting. So let's do if, and then check e.key. If that is equal to arrow right. Now sometimes, I forget, I think it's on other browsers or something, it can also be right, like this. So we want to check for that as well. So if that's true, then we want to call a function called move right, which we haven't created yet. Else if, let's say else if e.key, whoops, I forgot up here, we need to do or e.key. Okay, so we'll say if e.key is equal to arrow left, or e.key is equal to left, then we want to move left. All right, and I'm just going to copy this else if here and paste that in here and here, and then let's change this to up, both of those, and then this will be move up, and then let's change this, so just change all those to down. All right, so now we just need to create those functions. So let's do move up. So these functions are going to be really easy, actually. We're just going to change the dx and dy. So we're moving up, so that's the y-axis, so dy. And we want to set that now to go up on the y-axis. It has to be negative, right? And we're going to set it to whatever the player's speed is, in this case 5. So if I save that and I tap up, it goes up. Okay? And I'll get to being able to make it stop in a second. Let's just finish the rest of these. So I'm going to copy this, and let's do down. So move down, we're still dealing on the y-axis, except it's going to be a positive number for the speed. Okay, so let's do move right. Right is positive on the x-axis, so dx equals player speed. And then left is going to be negative on the x-axis. Okay, so now if I hit down, if I hit right, goes up, if I tap up, now I don't want it to keep going. I want it to stop when my key goes up, right? So what we'll do is in key up, I'm going to paste this in just because it's really simple. It's just a lot of typing because there's a lot of keys. So we're just checking to see if any of the arrow keys are hit, okay? Or if the key equals, I should say, any of the arrow keys. Then we're going to set both the dx and dy back to 0, which will stop it. So if I now tap right and let go, it stops, right? If I hold it down, it'll go, but if I let go, it stops. And now I can control my little character all over the screen. Okay, now he still goes outside of the canvas, so the last thing I want to do is some collision detection and just make it stop. I don't want him to bounce off, I just want him to stop. So let's go up to, let's go into new position, because this is where it actually changes position. And let's call detect walls. Okay, we could put it right in here, but I think it's cleaner to just put a function in. Okay, so to detect walls, let's first do the left wall. So this is actually pretty easy. So the left wall here is 0, right? It's x0. So we want to see if the player.x is less than 0. That means he hits the wall. So what do we want to do? We just want to keep him there. So we'll set player x at 0. So if I save that and now I go left and I hit the wall, I can't go any further. It just keeps me at 0. So that's pretty simple. Let's do the right wall. So this time we're going to do if player.x. Now we have to take into account the width, okay, because it's this side and this is the start of the player. So we need to account for the width of the player as well. And then we're going to say if that is greater than the canvas.width, which is the, in this case, 600 pixels. If that's true, then we want to just keep him at the edge. So we'll set player.x to the canvas.width, but we need to also take into account the width of the player, like that. All right, so now if I go and I go all the way over, he stops. Okay. So now we want to handle the top and bottom. Let's do the top first. Top is really simple, basically the same thing we're doing here, just on the y-axis. Let's say, so change this to y and then set y to 0. So now if I go up, can't go anymore. And then for the bottom, almost the same thing as this. So let's say bottom wall, except we're dealing with the y-axis and we're dealing with the player's height and we're dealing with the canvas height and height, and set that to y. Okay, so let's try the bottom, and there we go. So now we can move our player around, and if we want to change the speed, we can. So if I change this to, let's say 10, now he goes faster. So it's not, I mean, it's not a game or anything, but it gives you an idea of how to start creating games. You know, so you could create other objects and stuff like that. But yeah, so I think that's going to be it. I know this was kind of a long video. I will have this code hosted somewhere, maybe a code pen or something. I'll have that in the description. But that's it. Thanks for watching, guys. I appreciate it, and I'll see you next time.